Okay, in this lesson we're evaluating piecewise functions, which means I give you an x, you give me an f of x. So essentially we're plugging values in and seeing what we get. I want to talk a little bit about why these might be useful to us before we jump into sort of some more concrete delta math examples. So I have a piecewise function on my screen, and you can see that f of x is defined as 2x, so a linear function, right, with a slope of positive 2, for x being between 0 and 4, and then defined as just plain old 8 for x being from 4 to 10. Okay, so I want to sketch a graph of what this would look like. This will help us evaluate them, and also maybe we can tell a story that like fits with this graph. So let's say I have x and f of x, and let's say x is time, and f of x is miles from home. And just like a really simple example, so you guys have all experienced like traveling away from home, maybe you're going for a walk or something like that. What this graph would look like is it would, I'm just going to sketch it, I'm not being very precise here, but we'd have upward sloping function, right? Slope of positive 2. And then when we get to a certain point, we just have plain old 8. So this is going to be the line, we'll call it y equals 8. And then this point here, think about what this point would be. Well, this is where it goes from upward sloping to horizontal. So that would have to be the point x4. Okay. So this function could model, say I'm going for a walk, and I walk for about, I guess, 4 hours. Maybe I'm not going for that long of a walk. But I walk for a certain period of time, and then at a certain period of time, I stop. So my miles from home stops increasing and then stays constant. So maybe for the next 6 hours, let's actually say, we'll say blocks and minutes. I don't know. My units don't really make sense in terms of like realistic problems here. But we can imagine a traveling problem, right, where our speed changes, or we travel a certain distance and then we stop. Obviously, we need two different pieces of a function in order to model a situation like that. You guys, if you guys had physical science, I think you guys are my last batch that will have had physical science. You guys looked at graphs like this, similar to this, when you talked about distance, velocity, time, I think. Okay. So what we mean by evaluating piecewise functions is, let's say I want to know how far I am from home after 2 hours. Well, f of 2 would be, 2 is between 0 and 4. So the piece we're adding is make sure you're looking at the right piece of the function, right? So f of 2 would be just 2 times 2, 4, right? So I use the top piece because 2 falls in the top interval. But if I want to say f of 9, well, f of 9 is on my bottom interval. That's at my horizontal piece of the line. So it's f of 9 is just equal to 8. Okay, so we're just plugging numbers in and evaluating them just like you're used to. The only change that we're adding is you got to pick which part of the function we're using. So here's an example from delta math, and we'll do a couple values from this. So let's say I ask you for f of 4. So I have to decide whether f of 4 falls into this top piece or the bottom piece. Well, here the criteria are not equal to -1 or equal to -1. Well, 4 is not equal to -1, so that means we use this top piece. So f of 4 would be 4 plus 2 squared minus 6. What does this be? 6 squared is 36 minus 6 is just 30. Okay, easy enough. Let's say now I did ask you for f of -1. Well, it says for x equals -1, f of x equals -6. So that's all there is to it. Okay, so here's two different examples. So notice f4, 4 goes with not equal to -1, and then f of -1 goes with x equals -1. Right. we'll do one more. So here we have what seems like a more challenging example, but it's really the same. So I'm finding f of negative 4, and we have to decide what the relationship is between negative 4 and negative 3 to figure out which piece it falls into. Well, it's definitely not equal to negative 3, so we can eliminate that choice. This says x is bigger than negative 3. This says x is smaller than negative 3. Well, that's true, right? Negative 4 is smaller than negative 3. So we're going to use this top piece, and this looks like a parabola. Another way you can think of this is if I drew a number line, if I just drew my x-axis, right? That's really what your number line is just your x-axis. We would have 3 zones, or really 2 zones, right? So we'd have negative 3, and then we'd have x less than negative 3. And then we'd have x bigger than negative 3. Well, negative 4 would be definitely over here, right? The convention is these pieces go from left to right. I would always double check, but that is the convention. Okay, f of negative 4 then would be this top piece. That would be negative 4 plus 3 squared minus 3, and that ends up being 1 minus 3 is negative 2. So we'd say f of negative 4 is negative 2. That's all there is to it. Make sure you pick the right piece, make sure you do your arithmetic correctly, and you'll be good to go.